We are going to have a little quizzy quiz. Well, what is it over, Mrs. Ford? Let me show you. What do our quizzes always look like? The practice, right? So here we go. We're going to practice. All right, my friends. Now we are on the side, I don't know what the other side says. We're on the side that says practice quiz. All right, I went ahead because I had another old quiz. I went ahead and put it on the back. So we're on the side that says practice quiz because this is what your quiz tomorrow is going to look like. Okay? The back side has some extra practice, but this is what the quiz looks like. Got it? So there's going to be a problem, big, horrible looking equation that we need to solve. What do you suggest we do to get the ball rolling on this problem? Oh, come on. Somebody knows. Let's look at each side individually and clean it up. So on the left, I'm going to have x squared minus 4x squared minus 12x plus 8. Don't just blindly copy that down. You see what I did? What did I do? I distributed the minus sign, right? Okay, the minus 4. I distributed that. All right, what am I going to do on this side? I'm going to FOIL. What does FOIL stand for? First, outside, inside, last. You've done it for years, you can do that. So I multiplied, I distributed on the left and FOILed on the right. Okay, now what should I do? Combine my terms. So over here, I'm going to have negative 3x squared minus 12x plus 8. Over here, I'm going to have negative x squared minus x minus 12. Take a look at that, make sure I did that okay. All right? All right, now what am I going to do? Esty?
How did you get negative x squared?
I got 1 minus 2.
Add the x squared.
I'm going to add everything over because when I have an x squared equation, I want to have it set equal to 0. Now, this is my personal problem, probably not your problem. I don't like to have this guy negative. So instead of bringing this one over, I'm going to take this one that way. So I'm going to add 3x squared. It doesn't make any difference, folks. This is Lisa Ford's personal problem. You can do it however you want. Everything goes to one side, either side, doesn't matter. So over here, I'm going to have 0. Now, what am I going to have over here? 2x squared plus 11x minus 20. Charles, what am I going to do now? Well, if it factors, I would factor it. That's going to be kind of a hard combination. Charlie, what did we talk about this morning? What do we always do when we have an x squared equation? No. We use the quadratic. There you go. So most of you, I'm not going to say all, but most of you are kind of uncomfortable with factoring. And And with this combination of numbers, I'm not saying you can't, I'm just saying I don't wanna waste time doing it. I'm gonna use the quadratic formula. What's my A? What's my A? 2. B is, and C is, there you go. Then I just plug it in. X equals negative B plus or minus the square root of B squared, which is 11 squared, minus 4 times A times C, all over 2A. Right? Let's clean it up in here. Use your calculator if you need to. It looks like that's gonna be, what is that? Negative 11 plus or minus the square root of 281 over 4. And I believe, my friends, this is our lucky day. Because I don't think 281 breaks down. So guess what? We're done. Problem's over. Now, hopefully you're this lucky tomorrow, but if you're not, you'll just take whatever this is and try to break it down, right? Looking for groups of 2. Okay, so you have one problem like that. All right, now, we got a bunch of domain questions. So, for review, what do we have to pay attention to in the problem if we're going to do domain? Denominator, we know the denominator cannot be 0. What else do we pay attention to? If there's a radical, whatever's under it has to be greater than or equal to 0. Okay, so I'm looking at my paper. Oh, A has a radical, right? So I'm going to say 4 plus x, not the radical, what is under it? 4 plus x is greater than or equal to 0. Just solve it. So x is greater than or equal to negative 4. Done. Easy. All right, let's look at B. What about B? Is there a denominator? No. Is there a radical? Okay, wait a minute. If there's no radical and no denominator, then there's no problem, no issue, and what's your domain? All real numbers, or negative infinity to infinity, or you can say all real numbers, or you can write all real numbers. That's the simple for that. Okay, why is it all real numbers? Because there's none of that and none of that. All right, what about C? There's a denominator. So I know that whatever is in my denominator cannot be 0. So I solve it. Add 3 to both sides. 5x cannot be 3. So x cannot be, do this. Done. And then what about D? Well, this one's the biggest, because why? What's happening in D? We have a radical, so x plus 1 has to be greater than or equal to 0. And we have a denominator, so 2x minus 4 cannot be 0. Right? So this is going to be a 2-part answer. I'm going to have 2 pieces to my answer. What's this piece going to say? X is greater than or equal to negative 1. That's part of your answer. What does this one say? X can't be 2. So both of those go in the answer blank because this problem had both rules. flip it over, we don't have a ton of time. You wanna do the 2 hard quiz at the top, or you wanna do 3 hard at the bottom?
3 hard at the bottom.
The 3 hard at the bottom. Alright, here we go. Remember, these are extra practice problems. This is what your quiz looks like. Okay? What we just finished is what your quiz looks like. Alright, so here we go. We're going to solve this equation. What are we going to do first to start solving this? We're going to FOIL over here. Actually, would you agree that this side is already ready to go?
Yeah.
So I'm gonna leave all that alone, and I'm gonna FOIL over here. So x squared okay, we okay with that? Now what should I do? Clean this up over here so it looks like this one. So that's gonna be x squared minus 8. Don't these all go away? Now, what do we do at this point every single time?
Get one side equal to
Get
0.
one side equal to 0. Whatever side you want, it doesn't make any difference. This time, I think I'll move this and move this. So I'm subtracting x squared and I'm adding 8. Is that all right with everybody? So what am I left with? X squared minus 4x plus 11. Well, I know that one doesn't factor. So, Charlie, what am I gonna do? Yes, and A is 1, B is -4, and C is 11. Here we go. X equals. Uh, 4 plus or minus the square root of. I want everybody's beady little eyes looking up here right now, because I'm tired of this mistake. I'm gonna put b squared here, right? B squared. What's b?
4.
-4. Squaring means timesing by itself, right? What's -4 times -4? 16. Not -16. If you guys keep putting this in your calculator wrong, you're gonna keep missing it. Just square 4 and get 16. This is always gonna be positive. This thing right here is always gonna be positive. If you ever put a negative there, you're going to miss the problem. It's always going to be positive because you're squaring. B squared minus 4 times 1 times 11 all over 2. This one's going to be kind of bad news because we're going to get a negative, which is fine. It's going to have an I. So it's 16 minus 44, which is -28. Don't you even think about canceling. You can't until you simplify that radical. So first, let's pull out the I. That's what we do with a negative, right? And then we're going to break down 28. What's 28? 14 and 2. Okay. What's 14? 7 and 2. So what do we got? 2 2s. So 4 plus or minus 2 root 7 over 2. Should be an I. Thank you. Forgotten. Now, should you think about canceling? what can you cancel out now?
4 and 2.
You can cancel 2 into 2, 2 into 4, 2 into 2. Don't do it unless you can do them all. What?
So when you put 5, doesn't matter if you put the after 4, it's
Nope. So what's my final answer then? 2 plus or minus I root 7 over, well, over 1 or just over nothing, right? You can put it over 1 if you want, doesn't matter. Okay? And then, so you did the bottom, right? So now we've got, wait, no, I did the top one. Was I supposed to do the bottom one? Oh, well, I did the top one, it looks like. So what is the domain of number 2? And number 2 is this. What's the domain? I promise there's one like this on your quiz. So what is going through your head?
So like the top would be x plus 3 is greater than or equal to 0.
Yep. Jameson remembers that whatever is under the radical has to be greater than or equal to 0. So that tells me x has to be greater than or equal to -3. Okay. What else? Jameson?
Then you can do x minus 2 cannot equal 0.
Exactly, because x minus 2 is a denominator, and denominators cannot equal 0. So that means x cannot be 2. So we put both of those in the answer blank. 2 problems, radical and denominator, so 2 parts to your answer. Okay? Alright? Okay. I will work out the bottom ones. We gotta get going. But I will work out the bottom ones and like hang the answers over there by the paper towels or something if you want to come by tomorrow and look at it and make sure. That's up to you. It's up to you. Your quiz isn't tomorrow though, is it? Your quiz will be Friday. So sometime between now and Friday, you can come by and check that out if you can. All right? Remember, your quiz looks like the one that says practice quiz. Okay? All right, here we go. Picking up where we left off yesterday, which was with vertical asymptotes. Now we're on page 9. Now, your job is to find and graph the vertical asymptotes. All right, so let's get back into asymptote work. What do you think? What should we be thinking about when we look at this problem? Okay, can the denominator be grouped? Remember you had a test question, you had to group it? So let's go ahead and do that. I'll group my bottom. So how can I group that? I can take out and squared and be left with x minus 4. those two. Just a negative 1. Nothing but a negative 1. What do I have left if I pull out a negative 1? A positive x, but a negative 4? And that's really good news because there's my match. Write down the match. One time. Just write down the match one time. Don't square it, don't write it twice. Just write down the match. Then write down everything else. Well, what else is left? X squared minus 1. And what do we know about x squared minus 1? It's the difference of squares. So on my denominator, I have 3 things. X minus 4, x plus 1, x minus 1. That's my denominator. How about my numerator? You notice anything about the numerator? These factorable. Be careful now. Think about it. How does that factor? X and X. Maeve?
-6 and +1.
Minus 6, positive 1, she says. Let's check it. X squared plus x minus 6x minus 6. Is that what I wanted? It sure is. See how she got negative 5 here? And negative 6 on the end? She's right. She's right. Okay. Everything's factored. Now what? We can cancel. Now, this is a big, big, big idea, but before we talk about it, I'm going to write down what's left. When I cancel that out, I've got x minus 6 over x minus 1, x minus 4. Everybody okay with that? Now, what does it mean when something cancels out? It means you have a hole in your graph. And the hole is a point. You automatically know the x. What's the x part of the point? Negative 1. Why is it negative 1? Well, isn't this the factor that canceled out? And we always use the opposite, always in parentheses. So that's going to be negative 1 by x. How do I find the y? Okay.
Plug it in for x.
You plug it in right here. You plug it in right there. If you try to plug it in the original, it won't work. So you need to plug it in the reduced problem right here. So what am I plugging in? Negative 1. So what's negative 1 minus 6? Negative 7. What's negative 1 minus 1? Negative 2. And what's negative 1 minus 4? Negative 5. Now remember, these are being times. So I'm getting negative 7 over 10. So on my graph, negative 1 is negative 7/10. Open dot. Left 1 down 7/10. What about my asymptotes now? There's 2 of them. Verticals. Do you know where they are? where do they come from? Where do I find vertical asymptotes? From the cannot be's. Where do cannot be's come from? The denominator. Where are my asymptotes? I have one at 1, and I have one at 4. Make sure when you're doing your pictures that you're labeling your asymptotes. Where is that? It's the x equals 1 and the x equals 0. Everybody okay? I know it's a lot, but we're in the big leagues now, folks. So it's a lot. We're going to keep practicing our vertical asymptotes, and now we're going to throw in some horizontal asymptotes. Okay? So take a deep breath. Will this problem have any holes? Will I be doing any work with holes in this problem? Why not, Kate? There won't be anything that cancels. How do we get holes? We cancel. It's the only way. Can't cancel, not gonna have any. Nothing cancels in that problem. Are there any vertical asymptotes? Yeah. Where will the vertical asymptote be? At x equals -3. Where do vertical asymptotes come from? The denominator, right? Just like domain, we look at the denominator. Now the horizontal asymptote is tricky. Here's how you find it. When I look at this problem, I only look at the x's. So I ignore everything else, I only look at the x's. If I only look at the x's, I have 2x over x. Y equals 2x over x. Well, wait, what's 2x over x equal? Just 2? That is your horizontal asymptote. Your horizontal asymptote is at y equals 2. The x's cancel, 2. That's it, that's all there is to it. That's your horizontal asymptote. Let's look at the next one. What should I do first? Factor it. So how does the top factor? Plus 2x plus 2x minus 2, good. How does the bottom factor? X plus 3x minus 3, okay. So I have a lot going on, but does anything cancel? So this problem will also have no holes. There are 2 things in the denominator though. So what does that tell me? 2 vertical asymptotes. One at -3. Remember we're labeling x equals -3 and x equals 3. Now, when we do the horizontal asymptote, we only look at the x's, okay? In this case, we don't have exodus, we have x squared. That's what we look at. Whatever x's we got, that's what we look at. So what happens when you put x squared over x squared? 1. So your horizontal asymptote is at y equals 1. Because this is a 1x squared over a 1x squared, and that just makes 1. That's not too bad. Try C. C's kind of easy. When you draw your horizontal and your vertical asymptote for x plus 3 over x minus 4. You don't have to do any factoring. Where does your vertical come from? Who remembers? The vertical comes from the denominator. The denominator. Vertical comes from the denominator. So where's my vertical asymptote? 4. X equals 4. Where does my horizontal asymptote come from? So looking at the x's, and this time I have 1x over 1x, which is 1. So my horizontal asymptote is at 1. Remember, we're working our way toward graphing the whole thing. Okay. Now, D is equally easy, but I wanted to make sure you understand that you can have you can have asymptotes that are fractions. Here's what I mean. Where does your vertical come from? The bottom, right? Now look. You guys have been doing this in your head. You've been looking at that and saying the asymptote's at 4, and that's right. But what you were really doing was solving this equation. That's how you got x equal 4. It's okay to do it in your head, but this one's a little harder. So I'm going to set that equal to 0 and figure out where my asymptote is. Where is it? Negative 3/4 if I reduce. So here's negative 1, so negative 3/4 would be in here somewhere. And that's perfectly okay. Fractions are okay. Now where's my horizontal? We got 3x over 8x. What is that? 3/8. So y equals 3/8. And remember, just get it generally in the right area. It doesn't have to be perfect. It's less than 1. All right, tell me what you know about E. What would you do with problem E? Factor the bottom. And how would the bottom factor? I think somebody said it. X plus 2, x minus 2. Jordan, you're sick, honey. Good. Feel your head down. This one looks quiet. are my vertical asymptotes? Negative x equals negative 2. And x equals positive 2. Now, everybody okay with that? The horizontal is tricky this time. Does anybody see, look at the original problem. Does anybody see anything that's a little bit unusual about this problem compared to our other ones? Well, the top is a plane x, and the bottom is an x squared. Okay, can't box those. Remember how you're drawing boxes? They gotta match. If you're gonna box them, they gotta match. And you always have to box the biggest power. So I need to somehow box x squared. That's the biggest power. But I know what you're thinking. Mrs. Ford, there's none on the top. You're exactly right. So I'm gonna go ahead and put 0x squareds on top. Because now I can box them. I have 0 x squareds over 1 x squared. What is 0 divided by 1? 0. So your horizontal asymptote is at y equals 0.
Just like the denominator divided into 0, not like what you want, the number that you want to do that.
You want to make the biggest power. Wherever the biggest power is, it can be on top or bottom. That's what you have to box. You have to box the highest power you've got. And if it's missing, you put in a 0 for it. Which is what I did. Alright, let's look at F. Is F about the same thing, you guys? What are you going to do first? Factor. You always want to factor anything that you can. How does the bottom factor? -4, +1. I see a couple of heads going like this. Let's check it and see what's wrong with it. Won't that give me a -3? So I'll make this positive and that negative. Leo, is that right now? Where are my vertical asymptotes? -4 and +1. How do I get my horizontal asymptote? I box in, right? What do I box in? The highest power, go back to the original problem, the highest power I have. Well, what is the highest power I have? X squared. I have one of them on the bottom, but I have none of them on the top. So when I box that in, I get 0/1, which is 0. Here's something to stash somewhere, compare to. Anytime the bigger power is on the bottom, you're going to have 0. Anytime the big power is on the bottom. Well, what happens in letter G? Well, let's take care of business here. Do I have a vertical asymptote? one X down there, so there's only one asymptote. Now, how do I find my horizontal asymptote? I box in the biggest X, okay? So what is the biggest X I have? X squared. I have one of them on the top, but I have none of them on the bottom. So when I box them in, I actually get 1 over 0. Tell me about 1 over 0. Can't have it. Can't have it. That's called undefined. Look, he's going to type it in on his calculator. 1 divided by 0. And what's it going to say? Error. So what does that mean? This problem has no horizontal asymptote. Because when you tried to figure it out, you got can't do.
Like on a test, if a problem like this comes up, can you just say no solution?
No, you say no horizontal asymptote. Because your job is to find the asymptotes. Okay? We have a vertical. A vertical is x equal 2. We have no horizontals. What do you think? Oh yeah, yeah. I thought you were saying something about a slant asymptote, and I'm thinking, yes, you're right. How did you know that? This does have a slant asymptote, but that's not for us to worry about right now. Okay. Last one. What's going on here? Tell me what you think. First of all, be really careful. The top doesn't factor. Did you notice that's a cube? Okay, no. We don't do cubes right now unless they can group. And that can't group, it doesn't have enough terms. So done, don't mess with the top. Does the bottom factor? Yeah. How does the bottom factor? -2 minus 2. Now a minute ago I said if there's 2 x's down there, there's 2 vertical asymptotes. Not this time, because they happen to be the same. So there's one vertical asymptote, and it's at 2. How do we find a horizontal asymptote? We box in. What do we box? The highest power I've got, which is what? X cubed? So I got 3 of them on the top and none of them on the bottom. So when I box them in, I get 3 over 0. No horizontal asymptote. I don't know if you were, I really don't want to clutter up your brains with a bunch of stuff. You have enough to remember. But a minute ago I mentioned that if the big power, if the powers don't match, if the big one's in the bottom, the asymptote will always be 0. If the big one's on the top, there will never be a horizontal asymptote. Okay, always, it doesn't matter. Big powers on the top, no horizontal. Big powers on the bottom, it'll be y equals 0 every time. Okay? Alright, there's an extra practice sheet in here, and we'll look at that, but not right now. Right now, we gotta get started on our BFF cards. So, I need you, as quickly as efficiently as possible, I need you to count out 12 cards. Okay? 12 cards. Come on. Hurry up. 12 each.
Told us they got
Every
it.
person needs 12.
So we did a hike.
These are going to be, BFF stands for Basic Family of Functions. And there are 12 basic functions that you are responsible for knowing. Okay? Now, in the other classes, we have a BFF sheet that looks like this, and we have all kinds of stuff we have to know. You guys know. Here's what you need to know. We're gonna get started. I'm not gonna get all done. I'm gonna get a few of them done. Everybody needs 12 cards. He doesn't have 12 yet. Let's go. 12 cards. Any color, it doesn't matter. And you're making your own flashcards. So in a minute, we're gonna make the first couple. What has to be on your flashcard is the name of the function, the equation of the function, and the graph of the function. So name, equation, and graph. Now, how you design your flashcards, that's up to you. They're yours, you're gonna be studying them. A lot of times what kids will do is, on one side, they'll put the graph, on one side of the card, and on the other side, they'll put the name and the equation. You might want to put the graph and name on one side, and the equation on the other side. Well, however you want to do it, it doesn't matter. But those are the three pieces of information that have to go on the flashcard. Okay? So let's get started. We're not going to get them all done. These truly, when I said BFF, I don't know what went through your mind, basic family functions, but these truly are going to become your best friends, all right? These are important. We are going to learn these 12 functions. Okay? So here we go. The first one we're going to learn, I'm going to go off my sheet here. The first one we're going to learn is what's called, I'm going to give you the name, the equation, and the graph. You're going to put them on your flashcard. This isn't in your notes. This is on your flashcard. So the name of our first function is linear, also called identity. You are only responsible for one of those names, but I might call it both, so you need to kind of know they're the same thing. The equation is y equals x. And the graph is a perfect diagonal through the origin, a nice straight diagonal line there. That is your linear line, linear function. So all three of these things need to be somewhere on your flashcard. Two on one side, one on the other side. You put back and forth and work. Okay. Next, we're going to do maybe one more, and then so we have what's called the squaring function, also called the quadratic function. Anybody just want to take a wild guess what that equation looks like? Y equals x squared. That's the squaring function, also known as the quadratic function. Its picture is that parabola. So just so you know where this is going, in a few days, I will draw that picture on a quiz, and the question will say, which function is this? And you will say, it's the squaring function. Because you're learning to match up the name, the equation, and the graph. All right, we'll do one more. You've been really good today. We'll do one more. we have the cubing function. The cubing function. Want to take a stab at what its equation might be? Y equals x cubed. X to the third. There it is. This one's a little tricky to draw, so watch me as I draw it. I pretend like I'm drawing a parabola opening down, but I stop at the origin. Okay? And then I draw a parabola opening up, but I start at the origin. So it's got this squiggle action going right here. Starts opening down and then moves and opens up. That's a picture of the cube. Alright, now hang on to those. Tomorrow, or next time I see you, we'll get the other number. You certainly could start studying these three right now to lessen your load coming up.